Whether on research stations or on a journey to Mars, long stays in space require sophisticated technology. Humans are not made for space. Form follows function. This design principle takes on a whole new meaning in space architecture. Without pragmatism, we can't survive outside the Earth. And in order to not only survive, but also thrive during long stays in space, we need well-thought-out concepts.
Living in space. Is that even possible? But of course. The International Space Station has been continuously inhabited since 2000, with each crew staying up there for about 6 months. It will be a bit different in the future when we fly to Mars for the first time. If you're traveling there for several years in a small capsule, then you'll have to rethink the space architecture. And with the growing space tourism to the moon and elsewhere, utterly new forms of living in space will develop anyway. One major difference is the lower gravity up there. It implies completely different requirements than down here on Earth.
To this day, it is probably the largest experiment in history. The International Space Station, the ISS. A giant laboratory, over 1,200 cubic meters in size, orbiting the Earth at an average speed of 28,000 kilometers per hour. The inhabitants of the station are part of the experiment. Scientists want to find out whether humans can live in zero gravity over extended periods of time.
Weightlessness is a state of constant movement, whereas here on Earth, with its gravity, I always start from a state of standstill and have to initiate a step. I have to set myself in motion. I have to take action.
As creatures of the Earth's gravity, humans are not made for the weightlessness of space. They can live in a weightless state, but they constantly have to work against the effects of the lack of gravity. That is one reason why the International Space Station is also a flying fitness center. Every part of the human body is adapted to living on its home planet. The skeleton, the circulatory system, the organs, the muscular system. Our bodies are just not made for long stays in space.
Evolution has adapted humans to living conditions on Earth over millions of years. And that is why we will not be able to adapt to living conditions in space in just a few years.
Most of the ISS modules are more than 25 years old. When they were planned, stays of more than a few days, maybe even weeks, were not envisioned. That's why human needs were given little consideration. As longer stays in space have shown, it is also important for the crew to be able to see the Earth, like an invisible bond, keeping them in touch with home. The cupola, the dome-shaped observation point, is a popular place for astronauts to relax. Its windows are relatively large, which is not typical of space stations.
Each window is a disturbance in the continuity of the hull, which is under pressure and means a lot of weight. In other words, every window means a lot of mass. And windows have to be made of very thick glass because they're exposed to constant bombardment from space in the form of micrometeoroids. The windows on the cupola of the International Space Station, for example, are supported by thick shutters. Even when they're not in use, they are there to extend the service life.
The outer skin of the space station protects its inhabitants from small objects drifting through space, micrometeoroids or space junk. The ISS has multi-layered protective shields at particularly critical points. It is under constant observation from ground control to avoid impacts from larger debris. In the event of danger, the ISS changes its orbit, but there is always a residual risk. The crew lives in a machine environment. An incessant hum is part of everyday life. Life support systems, pumps, and fans create constant noise pollution.
Einige der Besatzungsmitglieder verwenden dann auch Ohrstöpsel.
Some of the crew members use earplugs to somehow block out this continuous loud background noise, mostly coming from the fans of the life support systems.
Ausgeht, das irgendwie abzudecken.
And the cabins are lined with special insulating materials to make the sleeping areas a bit quieter.
Noch ein bisschen leiser zu machen in diesen Schlafbereichen.
The crew operates in a pragmatic world designed for research. There is no top or bottom. Every wall, every square centimeter is used. Life in space is a challenge for the body, but also for the mind. Artificial light, no plants, no comfort. All this knowing that beyond that thin aluminum shell, there is only deadly nothingness. And the lack of gravity causes serious physical atrophy.
For millions of years, our circulatory system has been evolutionarily adapted to the fact that I am standing on the Earth, that my blood flows downwards, and that my heart has to pump the blood from my feet back up to my head and supply my brain with blood. If this is no longer the case, that is, the blood is weightless, then the heart no longer has to pump blood up from the legs, but instead pumps it mainly towards the head.
This means that the head is supplied with too much blood from the heart. Bodily fluids are distributed incorrectly. As a result, the head swells up and the legs become thinner. Due to the high pressure caused by the pumping of the heart, blood seeps out of the vessels and accumulates in the brain, increasing the risk of cerebral edema. The space station is anything but ideal for the human organism. The crews are under constant medical observation, and they are aware of the dangers while in orbit, most of them anyway. Humans dream of traveling to Mars. A mission to the Red Planet would take at least 2 years, including the return trip to Earth. To investigate the effects of such a long journey, NASA carried out an unusual experiment with the 2 astronauts and identical twins, Scott and Mark Kelly. Scott spent almost a year in space. His brother stayed on Earth. Extensive data was collected on various aspects of Scott's health, and at the same time, Mark was subjected to extensive tests on Earth to determine differences in the aging process between the two. Scott Kelly spent 340 days on the ISS.
That's impressive, yes. But at least astronauts on the ISS have the choice each time. If they don't like it anymore, they can go back down on the next mission. You wouldn't have that option on a Mars mission. So you'd have to keep people happy for 3 years. And that's why I think that on a mission to Mars, it suddenly comes down to things like design, that you feel comfortable, that it's somehow a nice environment, that you have free time. And that's a whole different ballgame.
Psychology will play a major role on a trip to Mars. You can't just go back. The Earth disappears from view, and you're cooped up in a confined space for a long time. Even the crews on the space station may experience psychological changes.
It changes the way people communicate with each other. Like from astronaut to astronaut or astronaut to ground station, you can already see small differences. And from these experiences that we have gathered there, we can see that we can possibly expect other psychological or far-reaching psychological changes when we undertake longer journeys in the solar system. For example, to Mars, or to one of Jupiter's moons.
Cosmic radiation poses another danger to travelers on Mars. It comes from solar activity, but also from the depths of space. Cosmic events, such as stellar explosions, release high-energy particles that are dangerous to humans. Today's spaceship hulls and spacesuits offer only limited protection against radiation. Cosmic radiation can also affect the electronics and computer systems on board the spaceship. On a journey to Mars, the crew and the ship would have to be heavily protected. To relieve the crew of the stress of such a long journey, even ideas from science fiction are being considered.
Dass man jemanden einfrieren kann, das
Unfortunately, it's not possible to freeze people. Probably not in the foreseeable future, not even in 50 or 100 years. But the fact that extended sleep phases ensure that less energy is consumed, that fewer psychological problems occur, that a flight may run more smoothly, that harmful radiation may also be blocked more effectively, because all the time is spent in the additional shell, so to speak, that is definitely something worth exploring and is actively being considered.
Yet, despite all the adversities associated with prolonged space missions, there isn't a single astronaut who wouldn't fly into space again in a heartbeat. And they would even accept all the risks and hardships of long expeditions, such as a trip to Mars. Curiosity and a pioneering spirit prevail. Anyone who chooses to go into space makes a well-thought-out decision.
Man gehört zu den ganz wenigen Menschen, die ausgewählt wurden.
You are one of the very few people who have been selected to go on a mission.
Oft schon jahrelang
You've been preparing for years.
darauf trainiert worden.
You've been trained for this. And I don't think there's a single astronaut who wouldn't go back to the space station if they were given a ticket.
Wenn man ihnen sozusagen ein Ticket geben würde.
However, if humans are to spend long periods in space in the future, the living environment must meet their needs. Aside from the technical and scientific requirements, there needs to be seamless interaction between the crew and the onboard systems, coupled with the utmost comfort, laying the groundwork for a harmonious time together.
Spaceships that fly from A to B were never intended as accommodations. That's why they were designed to be as small as possible. This only changed when we began to conceive of stationing people in space. The first person to pursue this idea was Hermann Nordung, an Austrian officer. He published a book in 1928 and described a rotating space station for the first time. Werner von Braun adopted this vision in the 1950s and developed it further into a 100-meter-wide rotating space wheel. But the first space station that people actually could live in was the Russian Salyut 1 in 1971. The mission was successful and demonstrated, yes, it can be done.
With Salyut 1, the Soviets launched the first space station in 1971. While they had lost the race to the moon, they made a clear statement with their space laboratory. The first and last crew consisted of 3 cosmonauts who spent 23 days on the station. Upon re-entry, catastrophe struck. A pressure equalization valve in the capsule opened too early and oxygen escaped. Upon recovery of the capsule, the 3 cosmonauts, Dobrovolsky, Volkov, and Pazayev, were found dead, asphyxiated. There was no further flight to Salyut 1, which was orbiting at an altitude of around 200 kilometers. In 1973, the Americans used a converted Saturn V rocket, the Moon rocket, to launch their Skylab space laboratory into space. From May to November 1973, a total of 9 astronauts visited the space station in teams of 3 and carried out numerous scientific experiments. Skylab was conceived as a heavenly Noah's Ark. The flying laboratory, which was created from the 3rd stage of the mighty Saturn rocket, offered plenty of space for research and living, including a library. No astronaut had ever enjoyed that much freedom of movement before. Sufficient space for the 3-person crew and the hundreds of experiments they were to carry out. The space station was the American answer to its counterparts in the Soviet Salyut series, which, like all Soviet-built space technology, were designed purely for function and never for habitability. Skylab also served NASA as a development laboratory for future long-term missions. With the advent of manned space travel, the duration of human spaceflight increased, and the lack of gravity showed its effects on the human body.
When the first astronauts on the Mercury missions were only in space for a day or two, it was completely irrelevant. They came back immediately. These effects didn't even come into play then. But since then, we have been extending the intervals that people spend in space. And that's why aerospace medicine is becoming increasingly important and interesting.
The astronauts spent up to 84 days on Skylab. They were aware of the dangers of weightlessness. A strict sports and gymnastics program was included in the daily to-do list, individually designed by the crews. There was a shower on board for hygiene and well-being. It turned out to be unsuitable. The astronauts had to catch the free-floating water droplets and rub them on their skin. The process was so ineffective that only washcloths and wet wipes have been used since then. There is still no truly functional space shower to this day. Water has a life of its own in zero gravity.
In theory, you could grow a water ball big enough to keep a fish in it, like in an aquarium. But that means that you can't take a shower or a bath in the conventional sense. Every drop of water that you apply combines with other drops to form a larger ball and doesn't flow off properly. In other words, I can't create the feeling of a shower. The experiments that were carried out in the Russian space station Mir or in Skylab were all ultimately shelved.
After the third cruise stay, there were no concrete plans for further use of the station. It was to remain in Earth orbit and later be revisited by the Space Shuttle, which was under development at the time. In 1986, the Soviets installed their largest celestial laboratory in Earth orbit thus far. Mir, the Russian word for peace, was the first space station designed for long-term operation. Humanity's first permanent outpost in space. The success of the Mir confirmed the Soviet Union's status as a space power. However, the laboratory orbiting the Earth also became a symbol of the end of the Cold War. In 1995, the U.S. shuttle Atlantis was launched to Mir. Americans and Russians shook hands. More than 100 astronauts and cosmonauts from all over the world visited the Mir before it burned up in the atmosphere in a controlled re-entry in March 2001, after 15 years of operation. The successful Russian space station served as a model and blueprint for the new International Space Station.
The Russians had essential experience in how to build a space station. What do we need to consider? The Russians' wealth of experience is practically the greatest in this whole area. They had the most astronauts and had launched the most rockets. That's why it was particularly important, and without that, we would never have been able to build the ISS the way we did, and within the time frame we did.
The International Space Station, ISS, jointly designed by Russia and America, is mankind's largest technology project to date. In addition to the rotating crew members on board, thousands of engineers and scientists work on the ground for the research station in space. They manage the experiments, maintenance, and repair work. The design of future habitats beyond the Earth is based primarily on the experience gained on the ISS. The ISS itself, however, offers its living community only a modicum of comfort.
Man versucht das Mindestmaß an einer bestimmten
We try to guarantee a minimum quality of accommodation, and this means that each crew member has a cabin, a place to retreat to, and that there are also various communal areas where people can get together and share a meal. That happens at least once a day. It's an event. Everyone comes together to eat. And the living area is made up of these individual elements distributed around this huge space station.
A living area that at first glance appears somewhat chaotic to the uninitiated. Every surface, every corner is packed with technology and equipment. Any space left is for working or for routine procedures, such as first aid and medical care, which also has to be specially adapted to the conditions in zero gravity. The Chinese space station is much more modern because it is newer than the ISS. The station, which is also modular and therefore expandable, has been orbiting the Earth since 2022. The station is brand new and an important part of the comprehensive Chinese space program. Now, taikonauts are also subject to the everyday challenges of life in zero gravity.
The food is quite different from that on Earth, and that's why I've brought a small selection with me. I'll start with this freeze-dried spaghetti dish, which was cooked and freeze-dried on Earth, so it's bone dry. Before you eat it, you have to add water, thoroughly knead it, and cut it open with scissors. Then you slide a fork under it and eat it. The ESA is very considerate towards its astronauts, asking everyone what they would like to eat. Then there's a celebrity chef who prepares it in cans like this. And of course, drinking is especially important in space. Unlike on Earth, there's no glass of water, just these aluminum bags, for example, with apple cider. They contain powder. You have to add water and mix it thoroughly. Then you put this plastic straw on the front, and now you can drink it.
NASA is already working on a new orbital station. This will not orbit the Earth, but the Moon. The outpost in space, dubbed Gateway, will serve as a platform for research and technology development. It will also serve as a relay station, a starting point for manned moon missions. As with the International Space Station, several countries are involved in the Gateway project, under the leadership of NASA. A central element will be the habitation module, called IHAB. It contains life support and medical care systems, as well as sleeping berths and work areas. The Viennese architecture firm Liquefier Systems Group also worked on the interior concept for the IHAB, which is the result of Japanese-European collaboration.
The main aim there was to create a living and working space for 4 crew members who would be stationed in Gateway for up to a month. So everything was integrated. We made the private cabins transformable. You can open them up. Then a kind of communal area, a so-called galley, or rather kitchen table. There's also space for scientific experiments, a place to work out. We tried to accommodate all these functions in one module.
The IHAB will have 4 docking ports, 2 of them on the sides where the cargo and lunar landing vehicle can dock, and 2 more on the longitudinal axis as a connection to other Gateway modules. The station can accommodate 4 crew members for a maximum of 90 days. They have around 10 cubic meters of habitable space at their disposal. The functionality and safety of the crew are always at the forefront of such a design.
A module is packed with technology on the inside, and every single part must be replaceable and maintainable during operation. And to be sure that all these parts are accessible, a one-to-one model is first built on the ground, where you can make sure that every single device is actually accessible, operable, and replaceable if necessary.
Planning is always subject to the size of the rocket and the limitation of the launch mass. SpaceX's Starship promises new possibilities here. With a diameter of around 9 meters and its high payload, the huge rocket could transport much larger modules into space. The heavy-duty rocket is also the basis for the planned Loop space station, a concept by the European aircraft manufacturer Airbus, which was also developed by the liquefier architecture firm. With a height and diameter of 8 meters each, it has generous dimensions, and it is explicitly designed to meet the needs of its residents during a long-term stay in space. On 3 levels, the station comprises all the necessary life support systems: a separate deck as a living and communal area, a science deck with an airlock, and a payload compartment. The decks are connected by a tunnel that also serves as a greenhouse. One special feature is a 4-armed centrifuge designed to simulate gravity for the crew.
Using this as a training device would be great for astronauts, because the adaptation effect, where the blood moves more towards the head, this fluid shift, is of course prevented more by such a long-armed centrifuge, or by a centrifuge in general. It means you have fewer problems. And I would imagine that concepts such as these, involving artificial gravity, will definitely play a role again in future models of space stations and spaceships flying not only to Mars.
The interior of the Loop module offers space for up to 8 people. According to Airbus, the individual decks can be equipped with mission-specific instruments depending on requirements. Loop is compatible with other space stations, but could also be used on a mission to Mars. The multi-purpose orbital module called the Loop concept is intended for commercial use in space travel, as a rentable research laboratory in space, or as a hotel for space tourists flying in Earth orbit. Dennis Tito was the first tourist to fly into space in 2001. The American billionaire was the first private individual to be allowed to enter the International Space Station. The trip to space cost him around $20 million. In 2006, Anousheh Ansari became the first female space tourist to float through the corridors of the space station. These flights were made possible by the Russian space agency Roscosmos. It was not until much later that the Americans also entered the space tourism business.
The Russians sent Dennis Tito to the International Space Station as the first space tourist. The Americans didn't like that at all. They saw the International Space Station as a research laboratory. That changed abruptly in 2017, when the American government told NASA, "You need to commercialize the American part of the ISS too." Since then, NASA has charged $35,000 per person per day for the stay. But just 2 years later, they realized it wasn't enough to cover the costs. So they raised the price to $165,000 per person per day. That's still relatively low compared to the total cost of a trip to the International Space Station as offered by Axiom Space. They buy a rocket from Elon Musk and send the tourist to the space station. NASA's very own hotel room, charging a total of $5.5 million per person per day.
Axiom Space is the name of the space travel agency where you can book your trip into space. In collaboration with NASA, the private space travel company flies tourists to the International Space Station. But that's not all. The U.S. company is also planning to dock its own modules to the space station. Not only for tourists, but also for scientists with research projects. The modules are to have their own solar panels and a separate airlock. This would make them independent of the rest of the space station.
In principle,
the International Space Station is a modular infrastructure that can also be used in that way. You can simply undock a module and send it into orbit so that it can burn up and land on Earth. And then you can dock a new module to maintain or expand the space station.
Based on the first Axiom Space modules, a separate space station detached from the ISS is to be built in the future. A further step towards the commercialization of space. Some of the people transported to the space station by Axiom Space already have research assignments and are taking experiments with them into space. But there will still be people willing to spend a lot of money as tourists to experience the inhospitable and uncomfortable confines of the ISS.
It's a bit like going to a mountain cabin, isn't it? There are a lot of people who want to climb Mount Everest and conquer the extremes. And there may be some level of comfort at the base camp, but probably not much. It's simply a different kind of tourism.
A private flight to the International Space Station currently costs around $60 million. And apparently there are enough companies and private individuals who can and want to afford such a ticket. The precious few seats are sold out long in advance. So there is a need for additional living space in Earth orbit.
NASA is also funding other space stations from commercial companies. And the largest of these will be the so-called Orbital Reef, a station for both research and space tourism, a joint venture between 3 large space companies.
The U.S. companies Blue Origin, Sierra Space, and the Sierra Nevada Corporation are planning to realize this commercial outpost in space. Blue Origin founder Jeff Bezos describes his station as a mixed-use business park. He is not primarily interested in space tourism, but in creating a basis for manufacturing and colonization of the Earth's orbit. The concept was tested by NASA and approved.
Die Raumfahrtagenturen bereiten sich jetzt schon vor, eigentlich auf eine Ära,
The space agencies are preparing for a time when they will no longer build anything themselves.
und auch in
Everything will be built commercially and put into orbit.
dann nur noch die Räumlichkeiten
And the space agencies will only rent the equipment to do research, to establish and carry out certain experiments.
etablieren und Experimente durchzuführen.
After reviewing the concept, the U.S. space agency NASA awarded a $130 million development contract to Blue Origin. One of the main components of Orbital Reef is the Life Habitation module. It only inflates to its full size in space. This means it can also be transported into space using conventional rockets. According to the developers, the inflatable segments are made of a fabric that is more resistant than steel. The module is currently being tested for its resilience, even though the concept may already be outdated.
Das Konzept der aufblasbaren Module verfolgt eben, dass man
The concept of inflatable modules is that you can unfold a much larger footprint in space, while using a smaller rocket cargo hold to create more
mehr
volume.
Volumen dann zu generieren.
However, SpaceX's new rocket, Starship, offers the possibility of launching up to 8 meters in diameter into low Earth orbit, or even further.
Zu bringen oder weiter.
And that almost does away with the idea of the deployable module, at least for low Earth orbit. It's no longer necessary.
Das ist dann eigentlich nicht mehr notwendig.
The first private space station in Earth orbit will probably be launched before the end of the decade. Perhaps the first step towards the long-term colonization of space. The private company Gateway Spaceport LLC is toying with the vision of a large, rotating space station. It is to be assembled autonomously by robots in Earth orbit. Once the technologies for manufacturing larger structures in space are available, such visions could become reality. The idea is by no means new. In the 1957 Russian space film The Way to the Stars, for example, a huge rotating station floats in space. The idea of a space telescope is also shown. The film features all the amenities of a station on which the crew is not exposed to weightlessness, a concept that was also taken up by NASA in the 1970s and by numerous filmmakers.
Science fiction films were the first to try to solve the problem of non-existent gravity in space by constructing large spaceships in which parts rotate. And when something rotates, as we know from driving a car around a bend, you're carried outwards by centrifugal force. And this centrifugal force could be used to create artificial gravity, because we humans have no sense of force at all. We can't tell the difference between a centrifugal force that pushes us outwards and a gravitational force that pulls us outwards. In other words, if I make a spaceship rotate, then artificial gravity is created in this rotating spaceship. And this has long been demonstrated in science fiction films. I still wonder today why this hasn't been tried out in a space station, because it would get around the problem that the space travelers already have to train constantly in these space stations. It's probably not technically easy to implement.
Megastructures in space with artificially generated gravity. In the Hollywood film Elysium, a space colony serves as a habitat for an elite that can afford to flee from an Earth that is sinking into chaos, a world of its own outside planet Earth.
Of course, you'd have to solve the question of where to get the raw materials for such a huge space station and how to get these raw materials into orbit. This is where the unforgiving reality of the rocket formula tells us that it's incredibly difficult to get any material into space at all. These are all things that can be solved in principle, but they simply don't seem economically feasible.
The construction of megastructures in Earth orbit, even a colony in space, are visions of the future. Only when humans have the technology to utilize raw materials in space could larger structures be built directly in Earth orbit. The maintenance, assembly, and manufacture of equipment and structures in space is also part of a NASA concept. Primarily, this concept is intended to repair, modernize, and refuel satellites in space. But the simulation also includes factories and power plants in space. However, its realization lies in the distant future.
What is the status of orbital space stations? Well, the first big one was the Russian Mir station. Today, we have the International Space Station and the Chinese Tiangong. In the not-too-distant future, we will have the Lunar Gateway, and what's more, habitats on the Moon and Mars. There will be new challenges. We need regenerative life support systems because that will save us expensive supply flights from Earth. And we need radiation protection. This is particularly important since we will be moving outside the Earth's protective Van Allen belt. All of this requires the cooperation of space technicians, biologists, doctors, and architects, who will have to implement all of this.
The moon as a playground for architects. In 2021, Chicago-based architecture firm Skidmore, Owings, and Merrill presented a concept for a settlement on the Earth's satellite at the Architecture Biennale in Venice. Entitled Life Beyond Earth, the design is intended to convey an idea of what a settlement on the moon could look like. The European Space Agency ESA was the firm's partner. The chosen location is considered a coveted piece of lunar terrain, the edge of Shackleton Crater next to the moon's south pole. The location offers almost uninterrupted sunlight for solar energy, a view of the Earth, and access to the water ice deposits that are likely to exist in the neighboring permanently shaded craters. A necessary resource within reach.
Today's concepts always assume that if you're planning a station on the moon or on Mars, you'll use the local resources. And on the moon, for example, with lots of sunlight and sand. This can be used for building. And so you can imagine making interlocking components that can be used to build a protective shell.
The use of local resources is a basic prerequisite for the construction of living space and shelter on planetary stations. How to turn the loose sand from Mars or the Moon into solid building material is already being tested.
The process we use for this is known as solar sintering. Solar sintering uses lenses to concentrate sunlight to such an extent that a bright spot is created, which becomes extremely hot, hot enough to melt stones. If you do this layer by layer, as you can see here if you look closely, you can create complex geometries.
Oxygen, water, food, and fuel. This means that planetary stations cannot be supplied from Earth in the long term. In order to be able to operate planetary stations in the long term, not only suitable living space is needed, but also technologies to create the necessary infrastructure. And it is precisely for this reason that the Moon has gained in importance as a new target. These technologies are to be tested on the Moon, which is easy to reach from Earth. The focus is particularly on autonomous systems and 3D printing.
It's not about sending a team of construction workers to the moon to build brick by brick. Everything has to be automated. In other words, there will be different robots working together in a concerted effort. This technology of swarm systems, or cooperative robots, is currently being researched and developed. But as of yet, there's nothing that could be used to build an extraplanetary structure.
Living on alien planets remains a vision of the future, but it is being worked on intensively, and technologies continue to develop. Scientists and engineers around the world are working on techniques and processes to make the construction of planetary stations a reality. Transportation capacity is always a decisive factor. The first dwellings, habitats, must come from the Earth. The Viennese architecture firm has therefore also developed a housing module, SHE, which only develops its full volume on site. Not an inflatable structure, but a cleverly folded mini-house.
It's folded because we are limited in size by the transport rocket, but then want to have as much space as possible available on site. And folding is one of the possible strategies for maximizing the space available on site. She has twice as much volume when unfolded as when folded, which means that you can transport two such habitats at once in a rocket.
A modular design with a mixture of living and working units brought along. The use of parts of the transport rockets and the raw materials on site, plus rovers for exploration and transportation of equipment. This is the concept of the space architects. This is the only way to create, grow, and maintain planetary research stations designed for long-term operation. But whether humans will ever want to settle far from the Earth is another matter. Inhospitable and absolutely hostile regions await them.
When I look at all the celestial bodies, they're not particularly inviting. I think that it's a cold, sober fact. Some have no atmosphere, others have too much atmosphere. Some are too cold, others are too warm. All of them are not particularly inviting. Of all of them, the most realistic place to really spend time would be Mars. Mars has a very thin atmosphere, but at least that's CO2. That also ensures that you have a bit of a greenhouse effect, so it doesn't get too cold there. And if I could say take as much as I wanted with me, then Mars might still be something one could imagine.
The basic prerequisites for long-term life far from Earth are closed systems and local food production. The Eden ISS project also serves to research such systems. With the help of the greenhouse in the Antarctic, processes for plant production in remote locations have been and are being developed. However, research into such technologies is also applicable to the planning of future living space on Earth. The idea is to use biological processes to create closed systems for surface water and also to generate energy. Under the keyword living architecture, important resources are to be conserved and optimally used.
The concept that we develop with our partners envisions a partition wall between the circulation area, that is the stairwell, and the individual living areas. And this partition wall consists of bioreactors, living architecture bioreactors, put together in modules. Each module has three functions: electricity generation, phosphate generation, and water purification. A process that continues from story to story. If I produce grey water on one floor, it flows down to the next floor and is purified there. Then it can be reused for flushing the toilet or for the washing machine. And so it slowly cascades down to the lowest floor.
Plants for oxygen production, water treatment plants, and biological recycling processes to utilize waste products directly on site. A concept for sustainable and self-sufficient use of resources.
The project is intended for terrestrial purposes, but the concept behind it is inspired by space technology.
The development and integration of closed systems is essential to enable long-term life support in space. And perhaps such systems will also shape the future of living on Earth.
So what is in store for us? Habitats on the moon? Yes, of course. There will be lunar tourism, no doubt. Habitats on Mars? Well, not so much for colonization, but more likely for research stations. That will be the case, and of course for affluent adventurers. They will have to wait a long time for the return flight to Earth. Space colonies? I don't think so. Not in the next 1,000 years. What for? But one thing is certain, in the next 7 to 8 years there will be private orbital stations, both for research and for tourism. Get ready for that.
There will be commercial space stations in Earth orbit in the near future. They will complement and eventually replace the aging International Space Station. Designers and architects are creating living quarters in space that will also make long-term stays comfortable for human beings, be it scientists or tourists. There will also be research stations on the Moon as a springboard to the distant goal of Mars. And perhaps one day, humans will set foot on the red planet permanently in order to colonize it.